My name is Sajeetharan. I work as a senior program manager in the Azure Cosmos DB team. I'm going to cover the awesomeness of Cosmos DB in this session. So I have seen a lot of hands. Probably you might have known some of the things that I'm going to talk about here today, but I will be diving into some of the developer-focused things. I'm going to put myself as a developer in this talk, and we will analyze from the developer-centric point of view. So when I talk about Cosmos DB, it's Microsoft Premier globally distributed, NoSQL. I would say not NoSQL because in the Ignite recently we announced it's going to be a distributed database supporting both NoSQL as well as relational with the announcement of PostgreSciTest. So we are the only cloud provider who is providing this feature among the databases that you see among different cloud vendors. So the next 45 minutes, I will talk about why Cosmos DB for developers. How many of you are developers? Great, I see a lot of hands. And then we will talk about how to talk to Cosmos DB or to interact with Cosmos DB using different SDKs, libraries, and to build your applications. And I will talk about best practices. So I have been given only 40 minutes. I will try to cover the bunch of things that I wanted to cover today. And finally, I will explain some of the tools that you can use to interact with Cosmos DB. And we will take the rest of the time for Q&A. Why Azure Cosmos DB for developers? The first one is a no-brainer. It's a completely managed service. So if you're building applications on cloud, you expect the cloud vendor to manage everything for you. And then we support multiple OSS APIs as well as if you're building applications using DocumentDB, if you're building applications using columnar database, if you're using applications using key value and graph, we support all of them. And with the introduction of Postgres, you can do relational things as well. And Cosmos DB being schema agnostic, which means you can directly store JSON data in the form you want. So you don't have to worry about how you want to store the data, what is the structure you need to follow, and things like that. And apart from that, Cosmos DB being globally distributed, that's the main advantage that you get being a cloud provider. And it supports multi-master, which means if you want to have 99.49s of SLA, and if you don't want your customer to get hurt, you can choose Cosmos DB. And finally, I will talk about some of the database-centric features, such as consistency levels. Say if you are having multiple regions, and if you want your data to be written in the same time without any conflict, you can choose Cosmos DB. And indexing is one of the things that we automatically provide out of the box. You don't have to create any specific indexes in order to manage your data. Again, 99.59s of SLA. If you're having a multi-region setup, you don't have to worry about region outage and things like that. We provide SLAs for queries that you perform, as well as for the insertion that you do with low latency. And when you talk about developers, we mainly focus about security, right? So we provide 3 ways of securing your data. If you're building mobile applications, you can use something called resource tokens, which you can use with React app or any of the standalone static web apps in order to interact with Cosmos DB. And when you talk about enterprise customers, you can bring your own key in order to encrypt the data in the format that you want, and we don't have any access to that, which provides a high security for your data, and you can build any type of applications using Cosmos DB. And if you're using the NoSQL API, which used to be called as the SQL API before, with the announcement that came from Ignite, we are rebranding the NoSQL API to SQL API to NoSQL for Cosmos DB, which means you can store your data in JSON and then use the SQL syntax to query the data so that you can use your SQL knowledge to interact with Cosmos DB and fetch the data and perform any operations. And when we talk about developers, the last 2 points are very relevant, and it's very important. Stored procedure support. So if you are writing any of the server script, programming language or concept on your backend, and if you want to integrate with your Cosmos DB, you can still do that. And UDF is some feature that if you want to do some modification on the data on the fly, as well as when you store some data, if you want to format something, you can use UDF, which is completely in JavaScript, which is the top programming language being adopted by developers. And finally, the interesting piece, which is the GraphQL support, which is coming along the way. So I mainly focus on the developer experience on Cosmos DB. GraphQL support has been asked in the last 5 years, and we are providing that out of the box. So if you are a Jamstack developer, Jamstack stands for JavaScript application, and then static applications using React or any front-end technologies that you can take. So you serve the static files, and then there is no intermediate layer. You directly talk to the backend. So we are providing the GraphQL layer on top of Cosmos DB so that you can build the front-end applications directly talking to Cosmos DB without writing your web API and things like that. So these are the features that I would like to highlight if you are a developer. So make a note of all this. And yeah, I talked about the features. So how to talk to Cosmos DB with code. How many of you, build applications using Cosmos DB on a daily basis? I see one hand. OK, a lot of hands then. So today, we will be mainly focusing on the SQL API, which we provide built-in, like native support, right? For OSS APIs, we recommend the customers and developers to use the native drivers, which are provided by OSS APIs, such as Mongo, Cassandra, and things like that. So I will be mainly focusing on the SQL API, because that is something that we are investing on, and also providing additional features that based on the feedback that we get. So how do we talk to Cosmos DB? So these are the fundamental terminologies that you need to understand when you talk about how to interact with Cosmos DB. The first one is the APIs. So you can refer APIs in two terms. One is the APIs, the underlying APIs that comes with Cosmos DB. So we call it NoSQL API, and then we have Mongo API, Cassandra API, Gremlin, and Table. And then we do have REST API, which you can use in your application to make any query or do some control plane operations. When I say control plane, which is the management operation. When I say data plane, which is the data operations that you do. So we provide the REST API support to do any of these operations. Say, if you want to create a container in Cosmos DB, you can still do with REST API. And the second thing is the languages and SDKs. So Cosmos DB supports so far 5 languages in the form of SDKs, starting from .NET, Java, JavaScript, Python, and Golang. Golang is something that we announced in the last month, which basically supports the CRUD operations that you want to perform on Cosmos DB. And then ORMs, if you are coming from the relational world, you might be familiar with ORMs. We do have the entity framework core support for Cosmos DB. If you don't want to understand or abstract what's happening on the database side, you can go ahead and use the ORMs. And finally, OSS drivers, which I will be talking in a slide. Any questions so far? I think we can take the questions at the back, but if you have any questions, feel free to raise your hand and ask. Cosmos DB REST API is the first thing that I'm going to cover today. So we provide the REST endpoint to manage both data plane and control plane operations. So here I'm talking about the API terminology. So as I explained earlier, we use the terminology APIs for our underlying APIs. So you don't confuse with the REST API and the underlying APIs. So we do have the 2 REST API support. One is to perform the data plane management operations, and the second one is the resource provider APIs for creating any resources on Cosmos DB. So you can follow this reference if you want to understand more about the REST API. I'm the program manager for particular feature, and if you want to give any feedback, you can do that. You cannot use this to manage account DB or keys. This is mainly for the data plane operations. Say, if you want to perform any query execution, if you want to execute stored procedures, if you want to get collections or database, you can use this. The other way you access, the data plane API is something that I talked about, data plane operations. The second one is the management REST API, which you can find in our central Azure Resource Manager documentation. Basically, you will call this endpoint in order to create the database account, collections, and things like that. I hope most of you know about the topology of Cosmos DB. I will come to that in a bit. But basically, even if you are using Azure SDKs or Azure CLI or PowerShell, behind the scenes, it calls this REST endpoint in order to create your resources. That's the fundamental point there. So if you have these questions, okay, I'm a developer, when to use this REST API and when to use the SDKs that we provide, right? So this is the one slide that explains when to use SDKs and when not to use the SDKs. So you can use the REST endpoint, say if you're working in an application which uses the SDK programming languages that we don't support, right? For example, Rust is one of the top programming languages that we don't have an SDK for. So if you're building some application using Rust, definitely you can implement the same features using the REST API that we provide, and then you can build the same logic. And if you don't find any other libraries for your application, you can go and use the REST API. And if you, for some reason, some of the customers of ours, even they don't want to use the SDK for some of their complaints reasons, definitely you can use the REST endpoint and re-implement. Some of the multi-tenant scenarios go with this approach because of the fact that they don't want to, have this maintenance inability to support the SDKs, and they are depending on us in order to provide some of the features that they want. So in that case, you can use the REST API. And if you're a developer, definitely REST is something that you deal with on a daily basis, right? So you can go ahead and use REST API to experiment and learn what are the operations supported. No, because these are the reasons. So we invest heavily on the SDK side. We do have engineers working especially on the performance and also the improvement of the SDKs across different devices, different platforms. So definitely, this is something that if you're considering supporting multiple devices, then you can, multiple environments, definitely I would suggest you to go with, SDKs. And SDKs incorporate some of the best practices, which I will be covering in a bit, in terms of performance, in terms of querying data. Definitely, I will suggest to go with, SDKs. And then we do have internal logging, which we call it as Cosmos diagnostic logs. So if you are an application developer, I am sure every one of you deal with customers on a daily basis, right? I've been on call with the customer in a continuous days. So telemetry is something I think even in the keynote, you must have listened to the message saying that telemetry is one of the important thing, and customer feedback, continuous feedback is something that we need to analyze and improve on. So we do have the capability on the SDK to provide that. And SDKs are heavily tested. We do have the end-to-end testing as well as the unit testing. Again, this is open, completely open sourced. So if you're interested in JavaScript or .NET or anything, you can go and search under Azure SDKs. And if you go to Cosmos DB, you can see the code, how we have implemented, and the test and things like that. Again, if you want to give us feedback, go to GitHub and then open issues and give your feedback and so on. In summary, use SDKs whenever you are building applications like enterprise applications, and if you are building to a specific language that we support. REST API, if you want to experiment. That's the message that I want to give. All right, quickly I will show a REST API demo. This is one of, that's me celebrating the demo. Probably it will go well, I guess. I'm not able to switch. 1 second. All right, so I have Postman. Postman is one of the widely used IDE or a tool to check a web request, right? So what I have done right now is I am connected to my account, which you can set on your environment. If you go to, the environment variable, I have set it as document DB, and then I have provided my connection string or the primary key to connect to my account. And these are the operations that we support on the Cosmos DB side. For example, if you want to list down the database in your front-end application, you can call the list databases, and then you would see the response, with all the databases that you have created on your account. And then you can perform some of the get operations. And then if you want to perform some create document or patch document or query document, all these are supported. So the message I want to give here is that if you want to explore, okay, what are the operations supported on the SDKs as well as on the REST API, you can play around with it. And one of the things that you can explore is the headers. So say even if you are requesting the REST endpoint using JavaScript, these headers are must, authorization token, and also if you're querying any of the data using partition key must be passed. So that is something important that you need to note. This is a quick demo that I wanted to show on the REST endpoint, but we do have a complete documentation that you can refer if you're building any applications using REST API. So let me switch to the next one, which is the Cosmos DB language support. If you're wondering what languages that we support, as a developer, you tend to work with any language, right? So we support all languages. You can use REST API for the languages that we don't support. But these are the SDKs in general we have, which are G8, which can be used in production. So starting with .NET, so far we have released 4 versions, V4 in preview, and then V3 is the recommended SDK for the end customer. So if any of your customers, or even as a developer, if you use V2 SDK, we recommend to move to V3 SDK. And then Java, we have V2, which supports both async and sync. We have seen most of the customers are using this version, but our recommendation is to move to V4, which have added multi capabilities in terms of performance, and we have done a lot more testing and added the network support and things like that. And Node.js SDK and Python SDKs are pretty new. So the features that are supported on Node.js and, .NET and Java won't be available on Node.js because of the fact that some of these developers giving feedback in order to improve, say, continuation token when you are issuing queries or cross-partitioning queries. Right now, those features are not available on Python and Node. So basically, you can implement some other alternatives using offset and limit. So that is one recommendation I wanted to give. And Go SDK is pretty new. So if you are performing any of the CRUD operations, you can go ahead and use the Go SDK for the time being. But the features are being added on the Go SDK. How many of you use Go SDK, I mean Golang, in order to build applications? I see no hands. But if you are an open source developer, I think if you're using some of the cloud native technologies, Go is pretty popular. So that's one of the reasons that we have added the support for Go. And also, as I mentioned earlier, we have the ORM support, which is for those who are new to ORM, which is the object relational mapper. It does have the capability to interact with Cosmos DB. For those who are not familiar, it is the abstraction layer so that developers don't have to focus on the entities that they map on the database. You can just write one line of code in order to store your data. So this is just a sample. You just dump the JSON that you want to store using C#. So these are the different holistic view of, I would say, the libraries, the extensions that we support for the entire Cosmos DB ecosystem. Starting with Mongo API, if you are using MongoDB API on Cosmos DB, we recommend the OSS drivers which are available. I will not dive into all of these, but Mongoose, Mongo client, all of these are familiar terms to you, right? So if you're interacting with Cosmos DB Mongo API, you will create a client using Mongo client and then does all your operations. And then Cassandra API is being one of the API that is being adopted widely. So you can use the Cassandra drivers, OSS drivers, which will natively support on Cosmos DB. You don't have to write any specific code in order to interact with Cosmos DB. You can just replace the connection string and then perform all the operations. Gremlin, it's similar to what I would say Cassandra and Mongo. We do recommend the Apache Tinkerpop library, which you can use to interact with Gremlin API. I think if you're building any of the graph workloads, I would recommend to choose the Gremlin API. And table API is in a maintenance mode, I would say, because we do have different different services providing the same capabilities. Azure Storage Table API, and then Cosmos DB also provides Table API. We do have the SDKs for the Table APIs, which comes with similar to, I think it behaves similar to NoSQL API. So you can explore .NET, Java, Python, and JavaScript. Postgres is something that we announced in the last Ignite announcement, which is added to the Cosmos DB umbrella. Again, you can use the native regular ORMs that you use to connect with Postgres, and then you can use the same connection string. So these are the different flavors. I know it's a huge list, but if you want to have a holistic view of drivers and what to use, probably you can refer this slide. That is the message I wanted to give. We have come to the core part of this session. This might be applicable, or I would say technical. What are the SDK best practices and common challenges that end customers see? So I'm going to share some of the problems that our customers have shared. So, and I'm going to talk about what are the best practices that you can apply when you are developing applications using our SDKs. Yep. So we talked about earlier, SDK is the main thing that complements Cosmos DB, right? Because SDK abstracts a lot of details, and it does the heavy lifting by doing most of our logics in the client side. So that is one thing that you need to note. Anyone here knows how many connectivity modes that we support on the SDK if you're using Cosmos DB SDK? I saw a lot of hands, but can anyone give an answer how many connectivity modes that SDK supports? I have some swag stickers I will give. You can give a random answer, right? If it's right, you will get swag, otherwise. Sorry? No? 2? I heard 2. Who said 2? 2 is the right one. So if you are developing on Cosmos DB, this is something that you must be aware of. We support 2 connectivity modes. I will come to that. I will come and explain like what it's all about. Before that, I think in order to understand connectivity modes, this is the fundamental topology of Cosmos DB, right? I know you must have been working with Cosmos DB, and you know it's a distributed database. But let me explain the fundamental concept. So I don't have a way to highlight, but let me put this way. So when you create a container in Cosmos DB, you must provide a partition key. Is everybody aware of that concept? So Cosmos DB completely work on the partition key concept, right? So partition key defines the logical partitions. That's how we group the data. All these documents are eventually stored in physical partitions. So you provide a partition key. In this case, it's a city. The partition key might have different values. Say city called London, city called NYC, and that's how we group the data. So those logical partitions will sit in the physical partition. So partitions are actually the machines, the physical machines that you see, or group of machines that we have in our data centers, which actually contains 4 replicas. So your data is replicated 4. So you can see the replication set that is shown here. These replicas are individual or physical machines that you might imagine inside a data center. So whenever you save a document, you actually store the data that is replicated in these 4 replicas, right? That is the advantage of Cosmos DB. We does that automatically. When you issue a query to save the data, we do that automatically. If you then replicate the account, so you can create single region account, you can create multi-region account. So if you replicate your account across multiple regions, that synchronization is done automatically. So the partitions also get copied to regions based on the configuration that you provide. So that is basically how we achieve high availability, and that's how we provide 5 nines of SLA for the end customers, which has lower redundancy in terms of replicating the data across regions, and also the synchronization becomes, it's not a hassle for the end customers. So I have explained the topology, but out of this slide, you just need to take away one point. So whenever you issue a query, it actually goes to the physical partitions that we have, which is actually the machines that I talk about, right? So under the hood, this is how it works. So I talk about 2 connectivity modes. I will come to that level. So you are basically issuing the request to the replicas that you see. So these you can actually imagine as machines that we have to store the data, whatever the data that you store. The first connectivity mode is the gateway mode, and the second one is the direct mode. I will explain what is gateway mode and the direct mode. So you can see there is a component that sits between our replicas where we store the data, and there is a client application. So this is called as the gateway component, which is a set of physical machines that we have, which actually does the request to replicas, what are the issues that you issues from client machine to the backend replica. So I will come to that point. So the gateway component is the one that hosts our REST API that I demoed before a couple of minutes. So the REST endpoint is hosted on the gateway component. It's kind of web forms that you can imagine, which comprises of multiple machines. So whenever you issues or the client issues requests, it actually reaches the gateway component, and then that gets distributed to the replicas, and that's being processed and sent back to the client. So what happens behind the scenes is that gateway receives the HTTP request, which opens the channels to the backend replicas. That's where we introduce the first connectivity mode, which is called as the gateway mode, to perform the operations. And then once the operations are executed, we send back the response using the TCP connections. That's how the first connectivity mode works. So you can imagine in the first connectivity mode, gateway mode, we have a component called gateway. That's what you need to take from this slide. In the second connectivity mode that you see, it's called as the direct mode. Instead of going through the gateway, I would say the network hop that you saw in the previous slide, the gateway component is completely removed. So there is no middleman between these two components, which increases the applications to get the response quickly. So there is no middle component that works between your requests. So obviously, the performance will be better. But I will come to the point about when to use each of these modes. So we do support two modes. One is the gateway mode and the direct mode. The main differences is that gateway uses the HTTP protocol. I hope most of you know about HTTP protocol, which is the web developers deal with on a daily basis. It is compatible mainly with enterprise environments. I would say most of the Cosmos DB customers are enterprise customers, right? That is one of the pain points that we see because we tend to adopt most of the enterprise scenarios. They do have proxies in their environments, so which have some set of rules which might block some of the users or applications to talk to, where you have certain ports being open. In that scenarios, gateway might be the option that you need to choose. Also, gateway uses HTTP connections. The number of connections are, I would say, less because of the fact that we eventually use the TCP behind the scenes in order to issue those requests to the replicas and get those. Also, gateway causes higher latency because I mentioned there's a middleman, the gateway component that sits between your application as well as your backend, our backend replicas. On the other hand, I would say direct mode, it uses the TCP protocols to perform the data plane operations. And then on the other side, yeah, that's 1 second. Yep, sorry. You would have lower latency because the middleman is removed. And then it supports, one of the drawback, I would say, higher TCP connections because there is, we actually don't know which partition to talk to, right? So which would result in scanning all the partitions, which causes high connections. So these are the differences that I would see. But if you are an enterprise customers who have a lot of security rules, we would tend to advise to go with gateway mode. But if you're interacting and if you need lower latency, then direct mode is the way to go. It depends on the scenarios. I talked about few scenarios, but yeah, we can jump into the next slide. Now we know that we have mental map of partitions that we talked about and how we store the data. So gateway component acts as a middleman, right? Now let's see from the SDK perspective, when you use the SDKs to access Cosmos DB, you create the SDK instance by passing the connection string and the key, right? So let's see what happens when you do such operations. Because this has led to some issues from the customer side. What happens is that SDK, in order to talk to the backend, it eventually requests some of the information that we have on the backend, right? So assume if you're talking to any of the databases, you need to have the database information and where it's hosted and what are the replicas it needs to talk to. So all these informations are fetched from the gateway component that I talked about. So when you issue a client, you create a Cosmos client and then pass the connection string and the key, right? this is what happens. So the issue comes to the gateway component, and then we fetch the account information first and the container information first, and the database information and the container information, and also it has routing information which actually maps to the partitions where we store the data. So these are the fundamental things when you issue the client. When you create a client, these are the requests being made. So one of the issues that you have seen in your application is the cold start. How many of you know cold start? Okay, there is one. Cold start is a common terminology if you're using, say, Azure Function or any of the serverless technologies. The first request that you make, it takes few minutes. So if you're not using that instance for a particular amount of time, it needs some time to spin up again, right? So that's called as cold start. So that issue is always, we define the same on the Cosmos DB. It's called as cold start. Once we have this information, once we have the account information, we fetch the container and then routing info. That's how the first request that you issue performs. Yeah, I think I talked about this in general. So whenever you create the first request, what happens on the SDK side is that we actually cache the information on our SDK so that the rest of the requests that you make on the same account, it doesn't take the time it used to take for the first request that you make. You get the point, right? So whenever you issue your first request, it takes more time because of the fact that we fetch all those information, and eventually those requests are cached, or those information is cached on the client machine. So you can, the further request that you send, it won't take much time. So that is another important fact. That's one of the common support requests that we get from customers saying that the first request is taking much time. So this is the reason that mainly because it costs much time. Let me show a small demo to show the fact that how the requests are being sent. Probably you might not have noticed in your application, but I need to go back. So I'm going to use Fiddler, and then I do have hopefully the demo works. Yeah, other thing is that I talked about different SDKs, right? Quickly, I will show how you can easily get started with Cosmos DB for the beginners who are here, who haven't used Cosmos DB before. So you just need to create a Cosmos DB account. That is no-brainer. You can go to Azure portal, create a Cosmos DB account of type SQL API or NoSQL. That's the new name that we have. Once you create that, and then you need to pass some informations about the region where you want to host and things like that. And then if you go to Quick Start, right, this is the place as the developer you need to land to. So we do have samples for different languages. So in this demo, I'm going to quickly use this .NET language. I hope here most of you are .NET fans. So I have already downloaded the code. But if you want to try this out, you can try this out. Just go home, or after this demo, you can try this out. Download the code, and then using Visual Studio, I have the code here. I have commented some parts because it issues all the requests, like create, query, read. So I have commented all those requests, and then I have provided the partition key and the endpoint, right? So let's see if the Fiddler is open, and if it's capturing the request. I hope I don't have any filters applied. So I'm executing, so I'm starting the application. This is the starting point of application, right? You can imagine your application that you built with any of the SDKs that we have. So it does actually create item. So you can see we are beginning the operation, and if I go back here, so this is what I talked about. The first three requests, right? You would see the first one, it actually fetches the account information. The Cosmos DB account, whether that is the primary region, and what is the physical partition URL, and what is the exact replica where we store the data. So that is the address of the partition or the machine that this particular request is going to reach out to. So you can see the replicas that I spoke about earlier. And then the second one is the PK ranges. So I talked about physical partitions, right? This is the partition key range, or the physical partition key that we need to use in order to execute any queries on this collection. So that is the second one. And then third, it talks about the container information. So which container we need to talk to, and is there any index that is already being configured, and what type of indexes we have configured. So these are the fundamental requests that we sent. And then obviously you would see the next request, which is to create item. So I have added a filter just to filter the basic request that we sent. But basically, the next request that you would see is the create item, which is not necessary. So I hope you understood the fundamental concept. Initially, those requests are sent from the SDK. So how do we avoid this cold start? I will come to that point. How much time we have? Oh, okay. Oh, is it? Oh. Okay, I have like 10 more slides. But so yeah, as a fundamental step, one of the things that that I talked about is the telemetry, right? We provide something called diagnostics, which you can enable on the SDK or the application in order to see what's happening on the back end. This covers from the end-to-end request from your client application to the back end. So you can see which user agent is sending the request and how much time it has taken to reach the network layer, and how much time it has taken on the server in order to debug some of the issues. So having the diagnostic information will help you to identify where it's causing the issue. So the issue can be on the client as well as on the server, right? If it's on the client, this is what we spoke about. The first thing could be the cold start. So how do we avoid cold start? One of the suggestions that you can use is issue a dummy request when you start the application that would have the request already being sent, so that you don't have to wait for the application to, whenever you issue your first actual request, it might not take time. And the second thing is the SDK provides something called create and initialize async method, which should actually send a dummy request, and so that the cold start won't be there. So this is supported on the .NET SDK and JavaScript SDK, so that you can leverage the same. I'm quickly going to skip some of the slide, and I will cover some of the important factors that you need to talk about. One of the other customer pain point is that multi-region account. So when you have multi-regions, one of the fundamental concepts that you need to configure on the SDK is the preferred region and the application region. When you have this preferred region, you have the capability to control the SDK to talk to those specific regions, so that you will avoid latency issues. For example, in this case, I have specified the containers, and then I have passed the application name, and there should be, Actually, there is a scenario that I wanted to present, but due to the time, I will skip that. Say you have a shopping cart application in region 1 and region 2. The region 1 is the US, and region 2 is the Southeast Asia. And your application is hosted on Southeast Asia, West US, which is where you have the Cosmos DB account, the first region, and the second replica of your account in Southeast Asia. And you see that high latency is caused in region 2. I wanted to ask this question to you, but let me give that answer, right? The problem is because the user wouldn't have configured the specific application region in his code. That's one of the reasons it's causing high latency. So how do we avoid high latency is that you need to, these are the 2 points. One is you need to configure the application region where your application is hosted, and which region you need to talk or issue those requests to. When you say application region, the SDK will automatically issue those requests to that particular region. But in this case, you get the preference by providing the priority. Say if you put Central US as the first, then those requests would be issued to Central US. So this is one of the common pain point that customers come to us saying high latency. That is the solution. And then the second one is the throttling. Throttling is one of the fundamental, when you are using Cosmos DB, the most common issue is the throttling. One of the things that we automatically do on the SDK is that retry. So SDK has the capability to automatically retry for 9 times. This depends on different scenarios that you do. It could be create or it could be read. So it depends on the scenarios, it varies, but SDK does it automatically. But even if the retries fails, then that is something fundamentally wrong on your account account setup configuration, or you might have configured the wrong partition key, which is not suitable for your data model. So you need to rethink and then improve the partition key, and also if that also doesn't work, increase the RUs in order to perform all those requests. So that is another thing that I wanted to cover. Okay, the timeouts is another common issue, right? So in a distributed world, we talk to multiple components in a distributed system. So you might have client, and then you have a bunch of network configurations, and then you connect to your database account. So the timeout can happen anywhere. So it could be on the client side, or it could be on the server side. So how do we eliminate those timeouts? I think if I go into those, it might take more time, but these are the two fundamental timeout scenarios that I would highlight. One is the CPU, and the other one is the connection limiting. Most of the customers come to us saying that there's a timeout on the client. They don't understand the fact that it is because of their CPU, CPU usage. So one of the things that you can do by enabling diagnostic is the CPU usage. So if you see a high CPU, I would recommend consider improving the instance size. This is applicable. So from the SDK, what we recommend is to use minimum 4 cores. That is our recommendation. So if you're using anything lower than that, definitely that is something the customers need to improve. And then the second one is the thread starvation, which is mainly because of the fact that when multiple connections are created, you can identify from the CPU history, this must be in a gap of 10 seconds. But if it's 10 milliseconds, if it's more than that, that's something fundamentally wrong. So you need to consider whether you are creating multiple clients within the application that is causing multiple connections. So we do have connections limits on the Cosmos DB side. So make sure that you don't create multiple connections. So yeah, these are the remedies, I would say. Create a singleton client in order to avoid connection issues, and then reduce the connection limit on your application instances. So if you are running using Azure functions in the consumption mode, that is something most of the customers tend to forget. So increase, you should move to standard mode. That is something you need to fundamentally know. And then gateway mode, if you're having an enterprise setup, because you might hit the connection limit. And then the TCP configuration. So this is something that you can do on the SDK. We do have the capability to enable timeout by setting this connection timeout property. On the service, I will quickly cover in 2 minutes. So this can happen on the client as well as on the service. On the service means on the server side, one of the interesting scenarios is the high latency, right? So how you can identify high latency is that if you have enabled diagnostic logs on your portal or even on the SDKs, you would see this parameter called backend latency in milliseconds. If it's something high, then that's causing either due to throttling or connectivity issues. Then you need to consider scaling out your database by moving to auto scale. If you're seeing high spikes at certain intervals, or you might need to merge some partitions, that's where some of these features that we support, merge partitioning and also burst, that is something that we announced recently. High latency is something that you can identify on the portal in Azure Monitor that we have enabled on Cosmos DB, and then you would see the request hitting. Then you need to adjust the RUs based on the queries that you perform. So server-side latency can cause into timeouts. In certain cases, it can be solved on the client side as well, based on the configuration that I saw earlier, or you need to change the database configuration. And then this is something automatically handled on the SDK side. Say if there is outage on certain region, the SDK has the capability to read out the request if you have a multi-master setup. So that is available on the SDKs. It will automatically switch those requests to the secondary region. You can see the timeouts can happen due to the replica, and then SDK will automatically retry, and it will come to a stage of status code OK. I wanted to show a troubleshooting demo. That is an interesting demo, but it might take more than 10 minutes. But quickly show, I mean, this is how you can troubleshoot any of the issues on Cosmos DB. You just need to go to metrics or insights blade, and then we have different tabs like overview, throughput, request, storage, availability. So if you're hitting any of the availability issues, if one region, you know, in Azure status, we display the status of each region, and if you see some issues happening, you can go to availability and see if there is issues on the availability. That is something that we provide out of the box. And then yesterday I was performing some throttling request. We should be able to see in the request, and you should be able to see some 429s, yeah, which are the throttling requests. So the remedy was to, you know, increase the RUs in order to perform those requests. So this is one thing, and then we do have diagnostic logs that you need to enable, and then you would be able to see the end-to-end telemetry from your machine to the server side. I will show a sample of the telemetry would look like if you enable, you know, diagnostic string on your Cosmos DB SDK. You would see something called which machine is calling this request. It's, I mean, actually, I mean, which machine is issuing the request and which physical address it's going to reach out to. And then you have some of the underlying terms like request charge, which is how we charge our customers, the RUs, and then the transport request timeline, like how much time it has taken on the transport layer, which is the network layer. And then you would see in how many seconds the total request was getting executed and where this information is stored, such as the physical partition. Yeah. So this is quite handy if you are debugging some of the issues. I think most of the custom issues that we get, we ask the customers to provide the request diagnostics so that we will be able to see where it's causing that issue. So as a developer, it is important that you enable the request diagnostics and then identify some of these key things that I talked about. All right. I think my time is up. Before that, I think these are some of the developer status codes that you need to be aware of. And I have mentioned whether those can be retried. The first one is 400, which means invalid content, which certainly you cannot retry. And 401s, which are usually caused due to the invalid authentication. Say, basically, if you are providing wrong resource tokens, which cannot be retried. And 403 is mainly because of firewall settings, which can be retried when you change the firewall settings. And it might take 15 minutes to take an effect. But certainly you can retry. And then 404 is certainly something that you cannot retry because the ID that you pass, which indicates that resource doesn't exist. So I would not recommend to retry. 408, it's internally retried to a certain level. But if you are reaching to a level that it costs more than 80% of the request fails, then that's something fundamentally wrong on your application or the database configuration. And then 409 is a common issue, the conflict issue. Like when you have single region, when you try to update the same document from multiple environments, then yeah, you cannot retry. That would result in 412, which is called as optimistic concurrency. The SDK automatically check the ETAG, and if you provide a new document, then it will, according to the ETAG, you can update it. So that is something you can retry. And then 413 is the max document size. So Cosmos DB max document size is 2 MB, but if you're using on Mongo API, it supports up to 16 MB. And certainly we will add that feature on the NoSQL API as well. 429 is something that I already talked about. SDK does retry. And then 449 is, yeah, you can retry after a certain time. And 500 and 503 are, most of the time we get these issues, say, when there is service unavailability, or when you create the client, you would see something called gone exception. That is basically this 503 error. This can happen due to two things. One is the connection limit and the timeouts. So I already explained what are the remedies for that. You can follow the same practices. Finally, I want to talk about, since it's more focused toward developers, you can use these tools in order to interact with Cosmos DB. I mean, yeah, you can use emulator in order to replicate the same what you are doing on the portal. And then we do have the VS Code extension. If you're building some of the native development scenarios, you can use the VS Code extension in order to connect to Cosmos DB. And then Portal Explorer, we do have a standalone Portal Explorer. By passing the connection string, you don't have to go to Azure Portal. You can connect to Cosmos DB account using cosmos.azure.com. And then finally, Azure Storage Explorer, which is being widely used by most of you, so you must be aware of that. How can we learn fast and start fast? This is one slide that explains different APIs, different APIs SDKs. You can get started with any of these by navigating to these links. And then, yeah, thanks for being a wonderful audience.